Hello, everybody. I am James Charlie. Happy to be here to be your host. So today, whether you're joining us from the office, from home, or maybe you're in the middle of the ocean, welcome. Most of us work on data problems from our desks. Our guest today, she built a production data pipeline in the middle of the Indian Ocean. Please welcome Anastasiia Stefanska, or Anna. By day, she's a senior data analyst at TUI. By night, she's a data superhero and a founder of Women on Snowflake. But this past September, Anna traded her desk for something much more extreme. She was selected for the OceanX hackathon aboard the Ocean Explorer research vessel sailing the Indian Ocean. For 3 weeks, she lived alongside marine scientists with nothing but satellite internet and a challenge: help them process ocean data faster. The result, she built a system using Snowflake that reduced scientific tasks from weeks to seconds. Anna, welcome. Thank you for bringing the ocean to us.
Oh, thank you, James, and thank you for such a lovely introduction. By the way, my internet is playing tricks on me today. It still pretends I'm in the middle of the ocean. So if my image freezes, I really hope it freezes on me smiling, because I'm super excited to be with you today and happy to tell the story. So where do we start?
Yeah, let's dive into the beginning. How does one do this? For the projects, I'm so super excited about everything we can talk about. So please take us away in terms of your journey and what you've built.
Absolutely happy to. Let me just bring my screen and start sharing my slides. I hope that that is visible to you. So
Mhm.
great. Happy to be with you today. And thank you, everybody, for joining. I'm really excited to share the journey. And I really hope that we'll have a fantastic conversation, and also that we'll have a lot of time to answer your questions. So please put them in the chat and we'll look at them later. Now I'm going to walk you through my journey from ocean to cloud, as I call my participation in OceanX hackathon. James already did a great job introducing me, so I won't repeat myself much. Just wanted to highlight that the opportunity of participating in a fantastic OceanX mission aboard the Ocean Explorer research vessel was a lifetime experience, and something I never thought I would be able to take part in as a data person, but also as a Snowflake data superhero, which is a program I'm a part of this year. I was honored to be the first Snowflake data superhero aboard the Ocean Explorer. Perhaps enough about me. I really want to tell you about the Ocean Explorer, the mission, and what I did on the ship. So here we go. The Ocean Explorer has a mission to unlock the ocean's sustainable potential for the benefit of people and planet. But that's, of course, a very ambitious mission. How I see it in simple words, in my perception, is we want to bring the science about the ocean. OceanX wants to bring the science about the ocean closer to the people. And this is why, as a part of the activities, which are numerous, and I encourage you to have a look at Ocean Explorer and other activities that they do, they organized a series of hackathons to which everybody could apply. And so I did. And as a data superhero, I was accepted to participate in a crossing between my yacht to Singapore, which took almost 3 weeks, in the Indian Ocean without seeing land. And this is where I could apply my data skills to the problems of the science, bringing together the power of ocean science, which happens aboard the Ocean Explorer, and the technology expertise, which I have as a data superhero, as an analyst and an aficionado in data. So the whole purpose of the hackathon is to make sure that we can unlock that ocean's potential and reduce the time to insight, democratize the access to data, and break the silos between different OceanX departments. And that's exactly what I did. James already mentioned that I took part in hackathon as a data person. My goal was to create data pipelines and a roadmap for OceanX to explore the potential of Snowflake technology. This is what I've done. And to be honest, no LinkedIn Live will be enough to tell you how many things happened aboard. And I would not try to tell you everything. So I really had to choose those small things and those meaningful contributions which I did during the hackathon. So I chose a couple of things. I chose 3 hacks. The first being completely off the grid. How do you do analytics? Where do you even start? And from that, we move on to the cloud and we explore the topic of biodiversity at scale. And I promise to show you demos along the way. Stay with me. This is actually more demo than a slideshow today. So the last but not the least, as I told you, connecting the dots between the teams and making sure the data is telling the complete picture is something that is very, very important for me as a data professional. And it's also important for OceanX to capitalize on the scientific research that they do and make sure that it works smoothly across the teams. Also, from on the ship to on the shore. This is a pretty exciting adventure. I was really blown away by the amount of technology and science that happens 24/7 aboard of OceanX. And so I want to show you what I did in terms of these 3 hacks, but also tell you a bigger picture. And in my first hack, I built an off-the-grid video processing application. It was completely offline. Because it's offline, I cannot demo it to you because it is, it works without internet. I don't want to switch off my Wi-Fi today. It's barely working anyway. So the first low-hanging fruit, which I identified as a part of scientific mission, which is in the middle of the ocean, is how to enable media pre-processing when your only internet is in fact the satellite internet in the middle of the sea. So I needed something which allows me to quickly work through the data which comes in a rich media video, high-res format, and it has to be locally hosted. I need to do some AI, which is also hosted locally. I use the models from Hugging Face. And I need a UI because not everybody runs Python in a console like I do. In fact, most people, I acknowledge, don't do that. As I promised, I will not focus much on this. I just wanted to briefly bring this up because it's actually the beginning of the data journey for this project. This is where the rich media comes into the ship from, for example, a submarine. And we want to make sure that we pre-process it, label it, tag it, and we also have a way of shipping those low-resolution frames to the cloud, to Snowflake Cloud in this case. Last but not least, I'm not a front-end person. Honestly, not a front-end person at all. I just told you I run my Python in console. But because I know that this is something that we would like to continue improving, moving on, I wanted to build a front-end for the team. And I used Streamlit for my UI. I used it as a building blocks, which is so simple that it took me, not a UI person, less than an hour to build an application which takes the video, parses the frame, and then pre-recognizes some images in it and sends the frames to the cloud. If you want to know more about it, my Medium article discusses exactly, actually all the hacks I've done today, but in particular focuses on which building blocks from Streamlit I have used for this app. Okay, so step 1, take the media data, slice the video into the frames, low resolution because I'm shipping them with the satellite, and then send it to the Snowflake stage. And this is where the next step kicks in. Remember, I told you biodiversity. So one of the tasks which scientists are exploring in marine science is to actually calculate the biodiversity by identifying the volume of the species and the amount of different species which exist at a given time. That usually happens by a very simple observations, like, for example, here, the video which is taken from the remote operated vehicle. Just a quick disclaimer, all source data in this demo is synthetic. So I'm not showing you the real OceanX data, but a synthetic data which I generated to mimic the real data from OceanX. And once we have those videos, we slice them into frames, we send them into the cloud. Now, we probably need to hire an intern to count the fishes in the frames? No, thankfully not. This is where AI SQL comes into play. This is an opportunity for us to reduce the workload from months of tedious processing of the video into the minutes. And this is where I'm going to show you how it's exactly done. So I'm exiting the full screen mode and I'm going into my second demo screen, which hopefully is showing. Okay, now I am in the image processing SQL. What I have here, let's just parse quickly what am I going to run in a matter of seconds. We have a stage, in this case OceanX Hackathon, video frames stage, which contains my images, which I just parsed and sent to the cloud. I have a file URL, which represents individual video frames. I'm going to use it in toFile function as an image to process it with the AI complete function, which allows me to take a model, I'm using 3.5 Sonnet in this case, and do exactly what I want to do with this image. So instead of somebody sitting and manually counting the amount of fish, ray, turtles, and corals on the image, I can do it at scale in a matter of seconds. Also, I don't want an answer which I won't be useful down in my downs of my pipeline. So I'm asking it to produce me a valid JSON. Let's see how long it takes. And maybe we would be a little bit lucky and it would even detect some fishes. Have a look at this. Under 6 seconds, we were able to process. In this case, I know we have 16 rows, 16 different images, and half of them are in fact frames without any particular fish. It's frame, no life. And I did it on purpose to show that it correctly detects that there is no fish, ray, turtle, or coral in the image. But as we proceed moving forward, you can see that for the images where there were in fact fishes, like the one I showed you on the slides, it correctly identified fish, ray, sometimes 2, sometimes 1, because there were in fact sometimes 2 rays, turtles, and corals. And you might tell me at this moment, if you're a data person, Anna, wait a minute, but what if it is wrong? And I have an answer for you here. It's the statistical property of the complete video which we're interested in. In this case, I am less interested in the individual frame count, but on the average across my recording, or perhaps a particular part of recording where I see that there are more biomarkers happening. So as you can see, with the help of AI Complete, a part of AI SQL family of functions, I'm able to process the image directly from Snowflake stage, which allows me to make it into the JSON format, which you can imagine I can down the line process and turn into the table. And in fact, I did exactly that. So what do we have from here on? We already had the demo. Now the last part. I promised you I will be connecting the dots in the end. So we are able to detect various data which comes onto the ship. And I just showed you example with the video data, but as you can imagine, there is a lot of scientific sensors which are coming in as well. And we're able to pre-process the data to store it in Snowflake. What happens next is data modeling from raw to staging to perhaps analytical layer, which we analysts are working with. But in this case, we won't be analysts, we will be scientists. And what scientists are interested in, they're interested in answering their particular questions about the data. What I did is I built a data model based on the example of the science and media data that was available on the ship, connected it with the semantic layer of Cortex Analyst, used it as a tool for Cortex agent, and put it into Snowflake intelligence to be able to answer the human questions about this data. It's a lot of words, I know. Now let me better show you what exactly I did. So I'm going to the Snowflake Intelligence tab. And this is the second demo which I want to show you. And the way it starts is, again, synthetic disclaimer. Synthetic data is going to be used in this demo. The way it starts here is, I want to know what are the measurements that we took in a mission. And I invented a mission. It's going to be a mission in Galapagos, which didn't happen in real life, but for the purpose of a demo, I created data for it. So we will have a data to look into. I will ask, what assets we have from Galapagos mission. And what happens here is a Snowflake intelligence on the back of it, powered by the Cortex agent, is planning to answer my question first. So it will try to find me assets, which is the way the scientific community calls the measurements associated with Galapagos mission. That means that we will need to check what we have in the missions and asset tables. Those is all the steps that the Snowflake agent does by itself. And we will look for something that contains Galapagos in the name of the mission. Snowflake Intelligence then is going to run me the query, which it created itself by the power of Cortex Analyst text to SQL. And based on the result, it was able to identify that the Galapagos mission, we have in our data model 4 measurements for CTD, conductivity, temperature, depth devices, 1 remotely operated vehicle measurement for underwater exploration, and 1 bathymetry measurement device for seafloor mapping. This represents somewhat possible measurements that a scientific mission can take. Let's zoom into this. I'm still assuming I'm a scientist, and let's say I'm interested in that ROV data. On what date did ROV happen? And again, let me open the details for you. And we see that they analyzing the request, they found the ROV asset from the previous query. And a fun fact here, the Chimera, which as you can see, the name of the table, Chimera Raw and Chimera Runs, is the actual name of the remotely operated vehicle aboard Ocean Explorer. The team is fantastic, and they gave names to a lot of different pieces of equipment. So ROV is called Chimera, and this is why I also encoded this data into the data set as a Chimera RAW, just to add some human touch to this and other means highly technical data. So we have successfully planned the next steps and we have executed them. And after we have obtained the results, the Cortex analyst is describing what it's seeing. So it's not just throwing me out some rows from the table, it's actually giving me a summary. Very useful. On September 8th, the operation started at 14 and ended at 14:08. Sounds good. And now the breaking the silo part comes in. As a scientist, I know that I had some videos shot from ROV while it was in operation. Let me try to find if those videos are available. Videos by default are not labeled in this data set with the mission tag. So it will be a more sophisticated way of finding data by joining it by the timestamp. Let's see if we can find it. Okay, so we're asking a fairly generic question. We want to know whether during the ROV we recorded any videos which we are storing in our system. The Cortex agent, again, analyzes our request, and it should find the data which corresponds to the video frames raw in my semantic model, with a timestamp between the previous query result. And it needs to modify the approach. Oh, fantastic. We have a fantastic way to demo the self-criticizing and reflection of Cortex agent. Sometimes the data might not exist in a format that the analyst or agent assume. In that case, it will get a result which it might not expect. What will happen then if it doesn't expect result? It will try a different approach, and this is what happens here. It needs to modify my approach. I'm really happy that we can see it now, because we can now also see with the power of text to SQL that it actually found the result. And since it knows already what the results are, it's also trying to bring some useful information for me. Look, it exactly found me the interesting information which I'm looking for. Yes, the video recordings were captured during the ROV dive, and it also gives me an understanding that there were some corals, fish, rays, and turtle synthetic data. I went wild. I asked to be having it all. So there was also some extra footage which had no marine life. So remember, we had different type of footage in our data example. Amazing. So when did we spot the most fish? As a scientist, that would be my next question. I want to know at which point we observed the highest biodiversity. Okay. Now, this is an analytical query. Now it's not just factually returning what it sees in data, but it also needs to be able to understand what I mean by this particular query. And here, of course, what I'm interested in, I want to know at which time did the count of the fish which is present in the processed video frames data has been the highest. And we have the count ready. 1404, 8 corals, 2 rays, 1 turtle at the same frame, and 14 fish, which is quite a lot. Fantastic. So you can see how we can build a bridge from the ROV data into the video frames data, but can we build it back? In this last part of the demo, I'm going to show you if we can I'm going to ask the question, at what GPS coordinates was the ROV at that time? Because that's what really matters. I not just want as a scientist to know where was the highest count of fish, but I want to be able to place it on my map. And I'm really trying not to make any typo mistakes here, but if I were to make them, which wouldn't be surprising, it would still recognize the question, and it would actually be able to correct me. And judging by what it thinks I am willing to ask, it would then modify the question to get the right answer. And there you go. The highest concentration of each was observed at these coordinates. And this is fantastic. This is where you can bridge the gap between the data silos, even if you don't have an explicit connection in your data. And this is what I built as a third low-hanging fruit for the Ocean Explorer ocean to cloud pipeline. Since we're at the end of my presentation, I just wanted to make sure that I don't forget to invite you to behind the scenes. I won't be showing how I created the Ocean Explorer data agent, but I had a fantastic opportunity to present to you how such agents are made using Snowflake intelligence. join me at Build, a virtual global free conference organized by Snowflake, and learn how to build an agent yourself, the like of the one I just showed to you. And for this demo, I will be using the IMDb data, so lights, camera, action on Snowflake Intelligence. I hope you're gonna like it. I definitely enjoyed playing with it myself. It's a movie recommender. So join me here. It's not that far away in time, 4th to 7th of November, in the time zone close to you. And I really hope to see many of you there. And I also hope to answer your questions. So with that, I thank you. And I will try to stop sharing my screen so we can jump into the discussion.
Yeah, thank you so much for that, Anna. It's super interesting to see what you've built in such a short period of time, even though, like, it's with the lack of internet, I'm sure a lot of us we already have nightmares about going to a hackathon and not having internet. You threw yourself literally into the ocean to make that happen for yourself. I have a couple questions for you, actually. So, uh, for when you were thinking about what to build, for the hackathon itself, like, why did you choose the projects that you did, as well as why did you choose the technologies that you did?
Yes, sure. So I'm a Snowflake user. So I'm working with a Snowflake at my day-to-day work at TUI, which is a travel company, and I love to travel as well. So when I came to OceanX aboard the ship, and I started exploring as a discovery what are the needs of the team, it came very clear to me that the needs of the science team aboard the research vessel are in fact quite similar to the needs of the data teams in any big organization, because you have your own team with whom you're usually sharing the data, but when it comes to a broader organization, the opportunity can be escaping from by default. So I leaned towards Snowflake because this is what I know works well for my company. Over 60,000 people, if I'm not mistaken, at my company, so quite large scale.
Wow.
And I thought if it worked for us, it can also work for Ocean Explorer. Secondly, when I looked at this rich media processing, it became super clear to me that the team needs something which works at scale. Because how many servers can you fit even on a very large research vessel? You know, capabilities are limited. And with Snowflake, you can scale at the matter of seconds and process super high resolution imagery as a frames of your high resolution video without the bottleneck of having to hire an intern to do that or things like this. So it was quite simple solution from the logical standpoint, because I think the AI SQL allows for those opportunities, but at the same time, Snowflake Intelligence democratizes the access to data beyond those who are writing SQL. As I said, I was the only person from the data team aboard, from the hackathon team. So my natural SQL and Python would not come handy, wouldn't scale. So I needed something which is human logic and human touch. And I think Snowflake Intelligence delivers just that.
Yeah, I love how you brought up that, like, scale's not just about, like, infrastructure. And I think a lot of us quickly go, oh, scale infrastructure, and that's where we go to. But, like, people power is also scaling. You don't have, in your case, you're the only data analyst there. So you aren't able to scale to do everything. So you had to provide a way for anyone to be able to access data and actually understand what's actually in the data as well. So that's awesome. I have another question for you. What's your most vivid memory about this trip? I mean, not all of us get to be in the middle of a vessel like this, in the middle of the ocean. Like, tell us a little bit more about that.
Well, I will have to get personal, because that most vivid memory is only in derivative connected to Snowflake. The first couple of days when we were aboard and we just left my yacht on our way to Singapore, the weather was not collaborating. And I have never done a big crossing before. So to be honest with you, James, I wasn't feeling very productive.
Ooh.
And my smartwatch proves that. So I built myself a private pipeline to parse the data from my smartwatch and send it into Snowflake with just a notebook and some tasks scheduled, so I could see how well I sleep. And the data shows, the data doesn't lie, that the first couple of days I did not sleep well. I had to stay very, put to be there. And I also made a small visualization in my blog about this, but I think the highest waves we had reached up to over 4 meters. And that's a roller coaster. That's a nonstop roller coaster. So my most vivid memory was how the ocean said hello.
Very big hellos. Yeah, I would be the first one going like, "Can I get off this ride now? Like, I'm done. I'll just swim back. Just drop me off here." Wow, that's amazing. It sounds like you had so much, not time, but like you had access and like the mental will to be able to like do more while you're on there. Like you said, you tracked your sleep and try to get some measurements off that. Like, can you tell us a little bit more about that? That's awesome.
Yeah, so what I did before I stepped aboard, because I knew I would be very busy, I wanted to keep track of what is in my journey. I actually took a physical journal with me, so I brought it today. It's just my scribbles here, but I tried to put something every day of what I've been doing. But some things you don't have to put manually, right? I don't have to check my clock every day. I could just set up an API call from the Snowflake notebook, schedule a task to run, and put it all into a stage as a JSON, and then automatically process it into a table. And there you go. I'm a data person, as you notice. I could have some of my biometrics automated, and I did that, and I'm really happy because on those wavy days I was not checking my clock, I was not checking anything. So that was a fun side project which I did before I stepped aboard, and then I was just like looking at it and comparing the public data from the weather to the sleep patterns which I had. Yes, it was the correlation and causation. So that was that case.
I'm looking at my notes here, and it says you created a board game as well while you're on the boat.
Well, that's stepping out of the comfort zone level next.
Yeah.
I told you everyone about the Snowflake part, and I built data pipelines as I do it for work, but I also it's a hackathon, so I also wanted to try something new. And OceanX had this fantastic idea of democratizing marine science to kids as a part of their educational efforts in a shape of a physical board game, which can be brought to schools and kids can learn what the scientists do aboard the research vessel. And then remember I told you Chimera and all the other gear, they have such fantastic names, Neptune, Nebule, there were a lot. So I felt those are like very naturally fallen into the pattern of a board game. I was luckily surrounded by fantastic game creators at A-Team. I could learn from them forever. And they very quickly brainstormed together with me a concept of a collaborative game. But the main bottleneck on the ship when you want to develop a game is you have to test it in a very limited environment. Everybody's busy hackathoning their own things. So what I did is I wrote a program in Python and run it in Snowflake notebook. And I ran my game 300,000 times to simulate how it will go. It's a probabilities, it's a common goal. So it's like a Monte Carlo optimization. So it's like you can run mathematics and it will converge. And I needed that to understand if the game actually works, if the numbers align. So on one side, I had my math, but I'm no designer. I had to bootstrap, and I had a fantastic partner in crime, my friend Zoe, who developed the board game visuals. He was also part of the hackathon. And with his background, he was a great co-founder, I would call him, on the board game experience. In the end, we have it ready to print. It's, OceanX has it ready to print. And I'm looking forward to see it come into schools across the world.
I'm definitely going to check that out. That's awesome. Well, we are at the end of the time. Anna, thank you so much. And for everyone, please make sure you sign up for Build and attend Anna's session. Like if you want to learn more about everything that she did and go deeper into picking her brain and understanding everything, that's a great place to make that happen. The comments, the links will be in the comments below, as well as the description. And again, thank you, Anna, for really bringing the ocean to us here on dry land.
Thank you, James. It's been my pleasure. And to everybody, ahoy and see you at Build.